Hello dear student, I am Pallavi Gajbhi and today I am going to share this video of Z transform. In mechanical engineering, unit 3 is Z transform, from which you will get two questions of 12 marks in question number 5 and 6. From question number 5 and 6 will be from Z transform. First of all, we see student, what is the definition of Z transform? If f of n is any sequence which is given where n vary from 0, 1, 2, then Z transform of this sequence f of n is denoted by Z of f of n, and it is given by summation n equal to 0 to infinity f of n. Since we are calculating Z transform f of n, here it is f of n into, this is the constant term, that is z to the power minus n, and since this is z to the power minus n, the notation is f of z. Here the power of z is minus n, that's why the notation is f of z, where z is a complex number. Similar to that of Laplace transform that we have studied in the third semester, it is Z transform, it is based on the discrete variable. Laplace transform is based on based on continuous variable, and Z is based on discrete variable. Okay, so we see first example, that is Z of 1. Now since this definition is there, Z of f of n is this, we have to calculate Z of 1. So in place of f of n, we have to put here n equal to f of n equal to 1. So it will be only z to the power minus n, can be written as 1 by z to the power positive n. And now we have to vary this n from 0 to infinity. Put here n equal to 0, n equal to 1, n equal to 2, plus and so on, since the upper limit is infinite. Now anything raised to 0 is 1, plus 1 by z, plus 1 by z square, plus 1 by z cube. This is nothing but a binomial expansion of 1 minus 1 by z inverse. Since 1 by z is the common term, this series converges to 1 minus 1 by z inverse. So after solving, this will be z minus 1 by z inverse, and hence in this way we will get Z transform of 1 as z upon z minus 1. So dear students, we have to remember this result for solving the further examples. Z transform of 1 is z upon z minus 1. Now there are some properties of Z transform. First is linearity property. If any sequence is multiplied by the constant, suppose a, b, c are constant, and we have to calculate Z transform of this. So Z does not act on the constant. Constant can be written outside, and Z of f of n will be calculated. Plus b is constant, so b is outside, Z transform of g of n. Minus c is constant, c outside, Z transform of b of n, where a, b, c are constant. Now second property is change of scale property. If Z transform of f of n is denoted by capital F of z, then Z transform of any sequence which is multiplied by a raised to n, if this f of n is multiplied by a raised to n, then we have to just replace this f of z as f of z by a. In place of z, we have to replace only z by a. This is nothing but a change of scale property. So again, to prove this property, we can use the definition z of f of n, summation f of n z to the power minus n. This is the basic definition. But in this case, we have to prove this result. So z of a raised to n f of n. So this complete term will be here, a raised to n f of n z to the power minus n. Now here a raised to n and z to the power minus n can be written as z by a raised to minus n. And as I told you, since the power of z is minus n, the notation is f of z. But here the power of z by a raised to minus n, that's why the notation will be f of z by a, and in this way the result can be proved. Now by using this, if we require find Z transform of a raised to n by using change of scale property. So here we use this change of scale property. In this case, a raised to n into f of n is there, but here it is not any sequence, so that can be written as 1. Here f of n will be 1, and we know the Z transform of f of 1 is z upon z minus a. So in that case, z upon z minus a, in this case z is replaced by z by a, z by a minus 1. And if you simplify this, Since Z transform of 1 is Z upon Z minus 1, if we replace this by Z by A, you will get Z transform of A raised to N. Next property of Z transform is multiplication. Again, if f of n, Z transform of f of n is f of z, and if this sequence is multiplied by n, then again we have to differentiate this f of z with respect to z and give there minus z. So again I am proving this property by using the definition. This is the definition of Z transform. Here we require derivative, so I have differentiated both sides with respect to z. If you differentiate this with respect to z, this is constant. The derivative of this term will be minus n z to the power minus n minus 1. So I have separated the power, since in the definition the power of z is only minus n. I have written this z inverse in the denominator and shifted this z on the LHS. So if you see here, this is nothing but the definition of n into f of n. In this way the property is proved. And if we have to take one example, the transform of n square. So n square can be written as, or Z transform of n, if we have to calculate first, Z transform of n, in this case multiplication, in the multiplication there is no term, so we can write down this into 1. So f of n will be again 1, whose Z transform is Z upon Z minus 1, and differentiate this and multiply by minus z. You will get the Z transform of n. To calculate Z transform of n square can be split as n into n. So here multiplication का n यहाँ पे है, into n is there, so this is nothing but f of n, whose Z transform is calculated now, and we have to differentiate this Z transform again and multiply by minus z. So in this way we can use the multiplication property, that is find Z transform of n into 3 raised to n. Here f of n will be 3 raised to n, whose Z transform is z upon z minus 3. Differentiate this and again give there minus z. Same example is there, n square 3 raised to n. So you can see the examples of multiplication in your result. In the next video I am sharing with you the next property of Z transform, that is division property. So dear student, kindly go through the notes which I have already provided to you. See the notes and write down them in the copy. Do not Xerox it. Write down in your handwriting and then refer this video. In the next video I am going to share the next topic. Thank you.